This video is for educational purposes. All materials used are intended for that purpose. In the freezing, absolute darkness of the interstellar medium, humanity's most distant explorer is facing its moment of truth. Its ultimate, final hour is fast approaching. For nearly 50 years, the twin Voyager 1 and Voyager 2 spacecraft have been hurtling away from Earth. They have crossed boundaries no human eyes will ever see, survived intense cosmic radiation, and become our only physical link to the mysteries of the deep galaxy. However, Father Time has given human technology its limits. And Voyager is whispering to NASA that time is up. Every single year, the Voyager space probes permanently lose about 4 watts of electrical power. Their nuclear batteries are decaying, their internal systems are dropping below freezing temperatures. NASA engineers have officially run out of non-essential components to turn off in order to preserve power. But instead of letting the Voyagers slip into eternal silence, NASA has given the green light to try a risky, all-or-nothing mission extension sequence. Engineers call it the Big Bang Maneuver. It is the ultimate cosmic gamble. If it succeeds, we buy these probes another decade of exploration. If it fails, we accidentally kill Voyager forever. To understand the sheer depth of this maneuver, we have to look exactly where the Voyagers are right now. Both probes are completely outside our solar system. They have crossed the heliopause and are traveling through true interstellar space. Voyagers 1 and 2 have passed the boundary of our Sun's influence. This boundary is referred to as the heliosphere. It took 35 years for Voyager 1, and 41 years for Voyager 2 to cross into interstellar space. This makes the Voyagers the first man-made objects to reach outside of our solar system. Voyager 1 is currently crushing records at over 15.7 billion miles from Earth, traveling at 38,000 miles per hour. Voyager 2 is tracking a different trajectory at 13.3 billion miles out. At these incomprehensible distances, how does NASA even talk to them? The answer is the NASA Deep Space Network. An elite global array of massive radio antennas. One base is located in Goldstone, California. Another Deep Space Network base is located in Madrid, Spain. The third Deep Space Network base is in Canberra, Australia. A radio signal can only travel at the speed of light, 186,000 miles per second. The Voyagers are so far away, communication requires patience. Right now, a command beamed from Earth takes 23.5 hours to reach Voyager 1. It takes another 23.5 hours for the probe's tiny 20-watt transmitter to whisper a reply back to Earth. That is a 47-hour round-trip time just to hear a faint, hello. For Voyager 2, the wait is slightly shorter but still agonizing, roughly 19.5 hours out, and 19.5 hours back. By the end of this year, Voyager 1 will cross the monumental, 1 light day, milestone. This means that a one-way radio message, which travels at the speed of light, will take a full 24 hours just to cross the cosmic gulf. That's a signal that's traveling at 186,000 miles per second. Both Voyager spacecrafts are running on borrowed time. Their power sources, the radioisotope thermoelectric generators, or RTGs, generate electricity from the natural heat of decaying plutonium-238. To save power, NASA has systematically turned off almost every instrument possible. Let's look at the list of instruments that were powered down to save energy. The cameras, permanently shut down in 1990 after capturing the famous pale blue dot photo. The ultraviolet spectrometer, off. The infrared interferometer, off. The photopolarimeter subsystem, off. The planetary radio astronomy instrument, off. The plasma science, PLS, instrument, off on Voyager 1 since 2007, and completely shut down on Voyager 2 in late 2024. All shut off to extend this ongoing 48-year science mission, well past expectations. Most crucially, on April 17, 2026, NASA was forced to make a heart-wrenching decision. To prevent a sudden emergency power drop, they pulled the plug on Voyager 1's low-energy charged particle LECP instrument. The LECP measures the intensity, energy, and streaming direction of ions, electrons, and cosmic rays. So, with all of these instruments off, what is left on? Right now, Voyager 1 is flying with just 2 active science instruments. Its magnetometer, which measures interstellar magnetic fields. Additionally, its plasma wave subsystem, which measures plasma waves in space. Voyager 2 is barely holding onto 3 active instruments. Its magnetometer, plasma wave subsystem, and its cosmic ray subsystem are all still active on Voyager 2. The spacecrafts are running out of energy, and their internal compartments are hovering just above freezing. This low power issue poses an existential threat to the 48-year Voyager mission. The remaining instruments are kept warm only by the residual heat of the few remaining live circuits. With no simple switches left to flip, NASA's engineers have devised the Big Bang maneuver. Under normal circumstances, operating a legacy spacecraft requires extreme caution. You modify one tiny setting, wait days to see the results, and carefully document the change. But the Voyagers doesn't have years of power to waste. The Big Bang maneuver is a highly complex, coordinated, real-time power reconfiguration script. Instead of turning things off piece by piece, NASA is commanding the spacecraft to deactivate several components simultaneously. At the exact same millisecond, the script activates secondary, ultra-low power modern software routines. These new commands are designed to maintain basic system warmth with far less electricity, but the process is very risky. Because the margins on Voyager 1 are dangerously thin, NASA is testing the Big Bang sequence on Voyager 2 first. Voyager 2 has slightly more electrical headroom. Throughout May and June of 2026, the massive 70-meter dish at the Canberra Deep Space Communication Complex, DSS-43, in Australia will beam this high-stakes code script to Voyager 2. If Voyager 2 safely processes the maneuver, stabilizes its power grid, and stays warm, NASA will deploy the sequence to Voyager 1 in July 2026. The pros of a successful Big Bang maneuver are historic. It means life extension of the mission past 2030. It means the micro-efficiencies gained will halt the freezing of the core electronics. This will grant both Voyagers enough operational power to survive until 2030, 2035, or even beyond. If the Big Bang saves as much energy as computer models predict, NASA plans to use the newly found power surplus to turn Voyager 1's low-energy charged particle instrument back on. We could literally revive a deactivated instrument over 15 billion miles away. The deeper the Voyagers travel into interstellar space, the more pristine the data becomes. No other spacecraft in history has ever reached this region of space. No other spacecraft being built or planned will reach this region of space for decades, if ever. But the cons of this maneuver are absolute, final, and catastrophic. The 1970s electronics on board are ancient and brittle. If the power swapping sequence is miscalculated by even a fraction of a millisecond, or if a legacy switch stalls, it will create a voltage spike. This power spike would instantly fry Voyager's fragile central computers or trip its automated safety software, forcing it into an unrecoverable defensive shutdown. There is no backup plan. If the Big Bang maneuver fails, the Voyager mission ends that very day. The probes will instantly become silent, system components would freeze over, and the twin space travelers will go dark forever. drifting aimlessly through the Milky Way for millions of years, carrying our story, our golden records, and evidence of our existence. This will be a true, all-or-nothing, Voyager mission maneuver. Right now, as you watch this, Deep Space Network antennas are pointing into the pitch-black void, communicating with a machine that runs on less processing memory than a modern car's digital key fob. This Big Bang maneuver isn't just an incredible engineering exploit. It is a testament to science and human perseverance. It is our absolute refusal to let our furthest explorers slip away quietly into the long cosmic journey. Whether the maneuver succeeds or fails this summer, the Voyagers have already achieved immortality. Thank you for watching. Please like, share and subscribe. Thanks again for watching Odyssey, Origins of Reality.